So today's class we are going to study chapter 4. So it's collisions between particles. So what's the we are going to study our understanding of classical mechanics to study collisions. Collisions you might have studied if you remember elastic collisions, inelastic collisions, है ना? And there were various cases. And what was important in collisions? हमारे पास जो important the information, like important fact from which we could derive things was we initially started with some conservation laws, conservation of mass, conservation of momentum, such that if particles before collision they had some velocity, they had some mass, or they had some momentum, m1 v1, if for example two particles m1 v1 plus m2 v2, after collisions they might go in some different directions, but the corresponding masses or velocities, if it's not relativistic, if it is at lower energies, which is classical mechanics which we are studying, the velocities may change into one form or the, but the net conservation laws should hold. They should hold, and that thing helped us to calculate many things. जैसे अगर smaller mass है, it will collide with a bigger mass or two equal masses. So the sort of problems you might have done in your earlier classes. What we are going to do, we are going to study the same things in the context of classical mechanics. We are studying in a sophisticated way, थोड़ा सा in a way which suits to the level of your class. ठीक है, ग्रेजुएट स्टूडेंट्स वो हो गया, हाई स्कूल स्टूडेंट्स है ना, हाई स्कूल स्टूडेंट्स also study classical mechanics. Then you have different degrees of studying the same things, है ना. You study mechanics, then you study relativistic, you go from classical mechanics to quantum mechanics, you go from quantum mechanics at lower energy to relativistic quantum mechanics, but you are studying basically what? Mechanics, motion of particles, है ना. And in mechanics also you study the Lagrangian formulation of mechanics, which we are studying. Okay, so now in that context we are studying collisions of particles, which you have been and the collision may not be one particle, they may be two particles, they may be n particles, and before the particles are going to collide they might have some mass, some energy, some velocities, and it's understood after the collisions. So it will get the resulting particles which will be collided, which they might have different masses, different velocities, and some amount of energy is also being dissipated, in the form of heat and other things. So we normally don't take that into consideration. That's very small, but that is there. So if you want to have processes, or if you want to have what I should say, more accurate descriptions of our classical mechanics, we will also take into consideration. Those will also account for those factors also. So now, if for example we are going to study disintegration of particles. So it's from the word it's itself clear, the particle is going to disintegrate. You have a big ball, अगर आपके पास कोई मिट्टी का ही है, आप इसको बॉल को डालेंगे, it will break into two, है ना. So it will not remain, the mass will not remain what it was after collision. Okay, this is a simple case. And what I have said, that there may be constituent parts in which that whole was disintegrated. So अगर आप ये है कि momentum हमारे पास है इस particle का, so again I said the law of conservation of energy and momentum or mass, it will come handy in our description of whatever this system is. So अगर हमारे पास magnitude P naught, so you can have so I straight away use law of conservation of energy. So EI will be equivalent to E1I plus P naught square है ना. What is this? This is basically what ये है ना, ये mv naught है, m1 v naught है. m1 एक इसके साथ कट जाएगा, ये आएगा ना m1 स्क्वायर v naught स्क्वायर. m1 एक इसके साथ कट जाएगा. So it's basically kinetic, another way of writing kinetic energy, the total energy of the system. So this is total energy of a particle before collision or whatever, or after collision can be this energy plus energy dissipated of particle due to particle A, energy due to particle B, and energy dissipated. It's the total energy of the system. You got my point? है ना. ऐसे m/2 mv स्क्वायर को हम ऐसे भी लिख सकते हैं ना, लिख सकते हैं. This is what we have written, kinetic energy or energy. So this is the, we have not included potential energy as such. So EI is the internal energy of original particle. And now if epsilon is the disintegration energy. Disintegration energy you know है ना, कोई भी पार्टिकल है, if you just इसको आप वॉल के साथ स्ट्राइक करेंगे, it is going to disintegrate. So in the process some energy is being dissipated in the form of heat or in the form of the energy is converted in some collision of the air molecules, जो भी है, that you can take into consideration. And the difference can be E1I minus E2I. ठीक है. तो dissipation energy ये है कि before collision, if it breaks into two particles, it's the initial energy, it's dissipation. The dissipation will give equivalent to if it has broken into two particles and whatever that remaining or remainder remains, it's this. And further, if we want to simplify it again, अब हम करेंगे काम, हमारा जो reduced mass problem है two particles के लिए, है ना, वहाँ हमने mu को ऐसे डिफाइन किया था ना, mu m1 m2 m1 plus m2 divided by m1 m2 के ऐसे है. ठीक है, either it's like this or this. ठीक है. तो we will write these in terms of that thing. So इसमें हम एक को, so इसको हम either we will put it, इसको right hand side में करेंगे, तो it will be so epsilon will be equivalent to, we will write this as p square by 2m, and इन दोनों को we just keep them on right hand side, so we can write it also as p naught square by 1 by m1 plus 1 by m2. बेसिकली ये है ना, ये 1 by m1 m2 आएगा इधर. ठीक है, ये m1 m2 आएगा, ये m1 plus m2 आएगा. This m1 plus m2, m1 plus m2 is equal to m. This is this m. ठीक है, so we'll write it in a compact form. Got my point? So this is m1 by m1 1 by ये m1 m2 आएगा, ऊपर क्या आएगा m1 प्लस, वो m1 प्लस में m2 यहाँ आएगा. Maybe if m1 is equivalent to m2, we can write it like this, 2m. If the you start with particles of the same mass. So m is the reduced mass of the two particles. And velocity of one particle may be p naught by m1, and velocity of the second particle may be p naught by m2. अब ये है कि if you remember in your earlier classes, do you know what is something called lab frame? Lab frame को पता है? And center of mass frame. What's the difference between laboratory frame and center of mass frame? Shower. What's the difference? So, a laboratory of so there are two frames. You should always remember there is a laboratory frame. And laboratory frame is that frame in which when you start the system before the particles got collided. ठीक है? आपकी measurement, your measurement when you are going to observe the system before they are colliding. ठीक है? And after the collision, when you take so there we are not interested in whether the system is conserved or not. जब हम so laboratory frame means a frame to begin with. Initially, when you are measuring the things before the particles are colliding, or before the system is interacting, or before this you are going to measure something. ठीक है, as it is. And center of mass system वो system है कि you are conscious of the fact that the total energy of the system is conserved or constant. ठीक है, this is the point. Or total momentum is zero or conserved or constant, जो भी है, that's it. अब क्या करें का what we are going to use, we are going to use just like we are going to yesterday use the knowledge of phonics in trying to study the trajectories of particles in a given centrally bounded system having a potential 1 by r or 1 by r square. अब यही है कि हम ज्योमेट्री के सिंपल जो वेक्टर अलजेब्रा के प्रिंसिपल्स को यूज करके वी आर गोइंग टू formulate this problem of collisions in that context. ठीक है, this is our job. So अगर हमारे पास let if we follow the book, let v and v naught be its so let us consider one of the resulting particles and let v and v naught be its velocities in the L and C system respectively. तो V and V naught be the velocity in the L. L means जहाँ भी L आएगा lab frame, and C is the center of mass frame. ठीक है, respectively. So V जो होगा, so if you want to write it, V can be written as V plus V naught, sorry, which will be clear, or if you just take it V minus V is equal to V naught, or if you square it, इसका V dot V करोगे, it will be V, इसको आप ये करोगे V minus V इसको हाँ V minus, ये थोड़ा V बड़ा है, dot of V minus V is equal to v dot v dot. So we can write it here. You can write it here. V square. इसमें 4 टर्म्स आएंगे 1 2 3 and so in the simplified form it will come out to be 2v cos of theta 2v cos of theta is equal to v naught square. So basically what we have written is if I draw it diagrammatically let's see. So we're going to make 2 circles. This circle, so I'll write it. So they are of the same radius, so I'll just write it. Now, so we are going to use our knowledge of geometry, जो भी है simple Euclidean geometry in the construction is angle theta. तो and जो आपकी vector algebra में, so if you denote it by v, the particle, and other part v naught है, and this is v. This is v and v naught. V naught, v बड़ा v. This one. This is v naught. And this is v. So like you use your knowledge of triangle laws. Now these will correspond to 2 orientation. Either this v minus v naught here v can be greater than v can be greater than v, or v can be less than v. So these 2 will correspond to. Accordingly, we make these 2 diagrams here. अब इस वाले में है the this is v. This is theta. This is a. Okay. So these 2 figures using triangle law of जो भी equality, where each side is given by velocity, है ना? And this is v, and this is v. The only thing is that in this case it may be v is greater than v, or v is जो v is less than v है, इससे sign flip हो जाता है. So the figure, the resultant may be from this side, slightly different from this. अब यह है कि ठीक है, अब यह है what the book says. In the former case means this one. Theta can have any value. Theta can have but in the later case, ये हो गया former, and in this later case, the particle can move only forwards. Only forwards. So which means C. So because basically dependence of this v है ना, v vector, ये theta पे dependence है, ठीक है? If v is less than this, so it will give a particular value to theta. उससे प्लस माइनस का साइन फ्लिप हो जाता है, एंड उसकी वजह से द डायग्राम में गो फ्रॉम द थीटा दिस एंगल, ठीक है? इट माइट गो यहां पर. सो अब ये देयर इज अ पर्टिकुलर कंस्ट्रेंट और कंडीशन दैट थीटा डज नॉट exceed theta max. So theta max यहां हमने लिया. थीटा मैक्स इज वी आर मेकिंग को उसके साथ अगर ये है सो इट्स द मैक्सिमम वैल्यू जहां तक थीटा जा सकता है, इसके ज्यादा नहीं जा सकता. ठीक है, आई वाज रॉन्ग, ये थीटा नॉट है. सो दिस इज द कंडीशन. नाउ so you just, if it's not थोड़ा सा इसको you take it as a fact, as a statement. Okay, what we are going to do, we are taking lab system and center of mass system, and we are trying to see particles का result net. We want to write them pictorially here, and जो orientation है cos theta क्या होगी? It can be maximum or it can be whatever that is, depending upon the sign of this. V is greater than or less than this. So these two diagrams will pictorially represent this thing, with the condition that theta does not exceed theta max. अब ये क्यों नहीं exceed करता है, इसका reason है. That's it. I'll just say. अब ये है कि the relation between theta and theta naught in L and C system. So it's maybe before collisions and after collision जो भी है. When you observe it in the lab frame and when you observe it after जो भी है change in velocity हो गया है system का, two particle system का. तो tan theta जो है, tan theta का वैल्यू आएगा, you can write it, tan theta is what? It's perpendicular over base. So we are going to use both sine angle as well as cos angle. So if it is इसका component along sine theta, तो नीचे वाला आएगा v cos theta. So it will be v naught cos theta plus v. v naught cos theta plus v, क्योंकि ये आफ्टर ये है ना, ये दिस थिंग. सो इट्स v प्लस, एक तो आएगा ये वाला आएगा v naught sin theta, दूसरा आएगा v को दिस प्लस दिस इज tan theta. Now again, if we are going to simplify it थोड़ा सा in terms of if we solve it this is theta naught, this is this is sin theta naught. So now what we are going to do, we are going to solve it for one is theta. So you see, this is theta and this is theta naught. This is theta, this is theta, this is theta naught. So we are going to solve it in terms of this orientation, angle between V and V, and this angle after collision जो ये है theta V naught के साथ. So इसकी orientation है, what's angle? Angle is the orientation between two velocities. ये theta है orientation between this and this, and this theta naught is its angle of V naught जिसका resultant है with regard to इसके साथ, chord के साथ, chord नहीं इसके साथ, we should extend it this line this way. So how can we solve it? We can solve it by this thing, sin theta by cos theta is equal to V naught sin theta naught divided by V naught cos theta naught plus V. तो हमको करना है, we have to solve it in terms of cos theta. So we are going to do it V naught cos theta plus V is equal to V naught sin theta naught cos theta by sin theta. और cos theta naught is equal to, इसको आप माइनस कीजिए तो so you You do it in the same way. I just straight away write the result. So cos theta naught का value आएगा, it will come out to be v naught by v sin square theta plus minus cos theta root of 1 minus v square by v naught square sin square theta. ठीक है. सो यू सॉल्व इट, थोड़ा सा इसको आप सॉल्व करना एंड सॉल्विंग फॉर बट cos theta naught इट शुड कम आउट टू बी दिस. हाँ, अब यहां से इट डजंट क्लियर कि रूट कहां से आ रहा है. सो यू जस्ट सॉल्व इट, है ना. यू सॉल्व इट इन टर्म्स ऑफ cos theta naught and we get this. Once you get this, तो we have to see the system. We are studying the system in the center of mass frame and in the lab frame. Lab frame में we assume that the system was beginning of the system we had some observation and center of mass frame में after जो भी happenings होगी. Provided we took total momentum is 0, ये condition लेके हमने लिया. अब what the if v naught is greater than v, the relation between theta and theta naught is 1:1. 1:1 क्या हो गया शाबाश. If theta is equal to if v naught is greater than v, है ना, v naught is greater than v, v naught is greater than v, तो ये आएगा ऑलमोस्ट 1:1. ये आएगा ना स्मॉल, v naught is greater than v, तो it will be very small, it will be almost cos theta. तो you can neglect this thing, so it will be 1 term में आएगा, more or less 1 आएगा. ठीक है, it will be 1:1. Is for each value of theta v, theta, there is only a particular value of theta naught. So for each value of theta, this orientation will do. There is a particular value of this. This is what he wants to say. However, if v naught is less than, ये हमने किया था ना when we started with the lab frame, हमने कहा था कि the velocity of the particle may be v, it may be greater or lesser than this thing. हाँ, v may be less than v naught, v may be, ये वाली केस, दोनों cases, v is less than v naught or v is greater than. In both cases, if v is greater than v naught, from this you can, it follows that the relationship of theta and theta naught is 1:1. And in case हाँ, अब ये है, this is important point. However, a relation is not 1:1. For v less than v naught, relation is not 1:1. For each value of theta, we have two values of theta naught. So you can interpret it, infer it from here. If v is naught is less than v naught is less than v naught is less than v naught is less than v, तो ये आएगा कुछ माइनस में आएगा, तो ये माइनस आएगा, तो यहाँ दो वैल्यूज आ सकते हैं, प्लस एंड माइनस. ठीक है, यू कैन इंटरप्रेट दैट वे. तो इसमें ये है कि बिगिनिंग द सिस्टम a particular orientation will have one-to-one map. एक आप पढ़ते हैं ना बाइजेक्टिव सर्जेक्टिव मैपिंग, पढ़ते हैं फंक्शंस में, पढ़ते हैं ना मैपिंग. फॉर ईच वैल्यू there is corresponds to only one value. Many one many है ना, in the same in that context you can understand it this way. अब ये कि why we are doing it? Because when there is a system of particles, for example, it's not necessarily it will break, the components of the system may break into two particles also only. They may break into many particles, है ना? So जो relationship of जो है internal energy, total energy, or energy of the individual particle into consideration. So you have to see all of these things together. So because in the center of mass frame क्या होगा, सेंटर ऑफ मास फ्रेम में ये प्रॉब्लम इसलिए अराइज नहीं होती है कि सेंटर ऑफ मास अगर हम लेंगे नॉर्मली उल्टे जो बॉडी होती है, इफ वी assume that mass is uniformly distributed, if the mass is uniformly normally distributed, तो after collision या after dissipation या after collision अगर ये we have, I'll take 5 minutes. अच्छा, I'll just conclude. Oxide things. So it will you have to the energy is equally dissipated. ठीक है, चलो ठीक।